Dear student, welcome to the video lecture series of Basic Electronics Engineering. In the previous video, we learned what is diode, its construction and working, that is nothing but VI characteristics. Now it is time to discuss what are the applications of diode. As we know, there are so many different types of diode like simple PN junction diode, LED, photodiode. Also, each diode is having different application. So let's study the application of simple PN junction diode as a rectifier. So the contents of this video are, first of all, we will discuss what are the learning outcomes of this video. That means after watching this video, what you are able to do. Then we will study the block diagram of DC power supply. The DC power supply is nothing but which convert AC to DC. In that, a very first block, that is nothing but rectifier. So in this video, a very basic type of rectifier, that is nothing but half-wave rectifier circuit. So we'll study the working of half-wave rectifier circuit in detail. Then we will discuss what are its advantages, disadvantages and applications of this half-wave rectifier circuit. Then we are going to summarize whatever we learned in this video. The learning outcomes of this videos are, after watching this video, the students will be able to explain the block diagram of DC power supply. They will be able to draw and explain the half-wave rectifier circuit along with the different waveforms. The students will be able to list out what are the advantages, disadvantages and applications of half-wave rectifier circuit. Now let us start with the block diagram of DC power supply. All the electronic devices such as TV, computer, microwave oven, music system operates on the DC voltage, and we know that the electric energy is available in the form of AC voltage. That's why this all electronic devices consist of a circuit which convert AC voltage into DC voltage. That circuit is nothing but DC power supply. So let's study the block diagram of DC power supply in detail. There are four basic building blocks of the DC power supply. The first block is nothing but transformer. As we are having the input in the form of AC, that is 230 volt RMS and 50 Hz, this AC voltage is very large as the DC voltage requirement for any electronic device is very less. It may be 5 volt, 10 volt, maximum 30 volt. That's why we need to convert this AC voltage into a small DC voltage. So the very first step, that is we have to use step down transformer. So this is the input signal which is nothing but at the primary winding side. So after the step down transformer, the output you will get a small AC voltage depending on number of turns. Now this AC voltage will be given as an input to the next step. So after the step down transformer, whatever the output of this transformer, that is this AC, will be given to the next block, that is called as a rectifier. So what is rectifier? This is a circuit which convert AC into pulsating DC, or you can say unidirectional AC. So the output of the rectifier, that is the waveform, will be like this for the full wave rectifier, and for the half wave rectifier the waveform will be only in the positive half cycle. So simply the rectifier circuit will convert AC into a unidirectional AC depending on the type of rectifier. If it is half wave rectifier, the output will be in the only positive half cycle, whereas if it is full wave rectifier, the output will be in its half cycle. So this output will be now given to the next block, that is nothing but filter. Now after the rectifier, the next block is nothing but filter. So this word itself indicates that it will remove the unwanted content. So what are the unwanted contents here? AC. So that can be removed with the help of filter. Now there are so many different type of filter, that is capacitor filter, C type, inductor filter, L type. So using that we can remove the AC content. So what will be the output of this filter? So this pulsating DC will be converted into a smooth DC. So like the output of the filter will be in terms of charging, discharging, so smooth waveform. So it will be more closer to the DC. combination of transformer, rectifier and filter, it is called as a unregulated DC power supply. Now in order to make this waveform more constant, exactly constant, we have to use next block, that is voltage regulator. So after the filter, the next block is voltage regulator. Now what is voltage regulator? The regulator is the circuit which will keep output voltage constant, even though there are some fluctuations in input. So whatever the filter output is there, that is not a constant DC. With the help of regulator, we can make it exactly DC. So this is a complete block diagram of the DC power supply. With the help of that, we can convert AC signal into a constant DC. So let's study the first block, that is rectifier, in detail. So let us define rectifier circuit. It is a circuit which converts AC into a pulsating DC, or you can say unidirectional AC. So this is the input signal. After rectification, you will get unidirectional AC. So this is very important step in the process of converting AC signal into a DC. Let's see what are the different types of the rectifier. There are two different types of the rectifier, that is low voltage rectifier and high voltage rectifier. The low voltage rectifier means the circuit which provides low DC output, whereas in case of high voltage rectifier, it provides high DC output. So basically the low voltage rectifiers are designed using diode, whereas high voltage rectifiers are designed using SCR. As in electronics, the requirement of DC voltage is very less. That's why we will study the low voltage rectifier. So there are two different types of low voltage rectifier, that are half wave rectifier circuit and full wave rectifier circuit. The full wave rectifier circuit again divided into two types, that is center tapped and bridge rectifier. So in this video, we will learn half wave rectifier circuit in detail. Half wave rectifier. In the half wave rectifier, the rectifier is on only during the 1/2 cycle of the AC supply. So the output is produced only in that half cycle, whereas the output is suppressed in other half cycle. The conduction takes place only 1/2 cycle of the supply. Hence the name of the circuit is called as a half wave rectifier. So let's see the circuit configuration of this half wave rectifier circuit. This is a step down transformer, whereas this is a simple PN junction diode, and this is a load resistance. Now let's see the operation of the circuit in positive half cycle. During positive half cycle of the secondary AC voltage, the terminal A is a positive with respect to B. So the diode gets forward bias. This is a diode, this is anode terminal, this is cathode terminal. So anode is connected to the positive and cathode is connected to negative. That's why we can say diode is a forward bias. As it is in forward bias, the current flows to the diode and then through load resistance in clockwise direction. So because of this load current, the load voltage is developed across the load resistance. Now let us see the operation of half wave rectifier circuit in negative half cycle. During negative half cycle of the secondary AC voltage, the terminal B becomes positive with respect to A. So the diode gets reverse bias as anode is connected to negative and this cathode is connected to positive. As the diode is in reverse bias, we can replace the diode by an open switch. So the current will not flow through the circuit and the output becomes 0. In short, for the half wave rectifier, during positive half cycle, the output becomes same as input, whereas during negative half cycle, the output is 0. Now what about the voltage across diode? During positive half cycle, as diode is forward bias, we can show it by closed switch. So the voltage across diode will be 0 ideally, and practically it will be 0.3 volt or 0.7 depending on the type of the diode. If it is germanium diode, then that Vd will be 0.3, and if it is silicon diode, then the voltage will be 0.7 volt. Now during the negative half cycle, as diode is reverse bias, that's why we can show it by open switch. So the voltage across diode will be the same as a transformer secondary winding voltage. Let's say if the Vm is a peak voltage across the secondary winding, then the voltage across the diode will be same as that voltage. Now this voltage is called as a PIV. PIV stands for peak inverse voltage. It is the voltage, maximum voltage across the diode when that diode is in reverse bias. We will study this parameter in next video in detail, but right now the peak inverse voltage for the half-wave rectifier, that is nothing but Vm. Now look at the different waveforms of the half-wave rectifier circuit. This is the input signal, which is nothing but transformer secondary winding voltage, which is the input to the rectifier circuit, and these two waveforms are of load current and the load voltages of the half-wave rectifier circuit respectively. And if you observe both this waveform, then IL and the VL voltage is available only in the positive half cycle of the input, whereas in the negative half cycle there is no output waveforms. Also the IL current has a same shape as that of the load voltage, as the load is purely resistive, and this IL is given by IL is equal to VAB, voltage across secondary winding of the transformer, divided by RS, that is nothing but resistance of secondary winding voltage of the transformer, plus RF is nothing but internal resistance of the diode, plus RL is nothing but load resistance. As the circuit delivers the power to the load during only the 1/2 cycle of the AC voltage, therefore this circuit is called as a half-wave rectifier circuit. Now look at this last waveform. This is nothing but waveform of voltage across diode. If you observe this waveform, during positive half cycle, as diode is off, that's why ideal voltage of the diode is 0. That is Vd is equal to 0 ideally, but practically it will be 0.3 or 0.7. This voltage is 0.3 or 0.7 depending on the type of the diode. For germanium it will be 0.3 volt, and for silicon it will be 0.7 volt. During negative half cycle, as diode is off, that's why it will be acts as an open switch. So the voltage across the diode will be the maximum. It will be same as the input. So let's say if it is a Vm is a peak voltage of the input signal, then the same voltage you will get across the voltage across diode, that is equal to Vd is equal to Vm. And this voltage is called as a PI. It's nothing but peak inverse voltage, means maximum voltage across diode when the diode is in reverse bias condition. So the PIV of half-wave rectifier is Vm. This PIV parameter is different for the different rectifier circuit. We must select the diode which has a PIV rating higher than the maximum possible negative voltage, that is Vm, to ensure the safety of the diode. Otherwise diode will enter into the breakdown region and it will get damaged. Now quickly I will show an animation for the half-wave rectifier circuit. This is the input signal, that is nothing but transformer secondary winding voltage. This is a diode, whereas this is a load resistance. If you observe, this blue color is nothing but it is a positive half cycle of the input signal. During that, this current is flowing through the circuit. This yellow dot shows the current flowing through the circuit, and this red color shows the voltage during negative half cycle. During that, the current is 0. The current is not flowing through the circuit. Now let's see the different voltage waveform for the half-wave rectifier circuit. This is the input signal, that is nothing but voltage across the secondary winding of the transformer, whereas this is the output waveform of the half-wave rectifier circuit. And if you observe the input and output waveform, during the positive half cycle of the input, the voltage across the load resistance, that is same as the input, whereas during the negative half cycle, the voltage is 0. Now look at the waveform across the diode. During positive half cycle of the input, the output, that is nothing but voltage across diode, is 0 ideally, or practically it will be 0.3 or 0.7 depending on the type of the diode. For germanium diode it will be 0.3 volt, and for the silicon diode it will be 0.7 volt. And during the negative half cycle of the input, the voltage across the diode is maximum, that is nothing but same as input waveform. Now let's see the advantages of half-wave rectifier circuit. The construction of half-wave rectifier circuit is very simple. Also, less number of components are required in order to construct the circuit, and the size of the circuit is also very small as the number of components are less. Now let us discuss what are the disadvantages of the half-wave rectifier circuit. It is having a high ripple factor. What is ripple factor? That we will study in the next video. But in short, we can say the amount of AC content with the DC, that parameter is nothing but ripple factor. And as we are designing the DC power supply, that's why this value should be less. Whereas in case of half-wave rectifier, we are getting this value as a high. So this is the biggest drawback of the half-wave rectifier circuit. Second, it is having a low rectification efficiency. So efficiency should be very high, that is 100% ideally. But it is giving a less efficiency, that's why it is one more drawback. Next is low transformer utilization factor. Transformer utilization factor should be very high, that is ideally 100%. But in case of half-wave rectifier circuit, again we are getting this parameter very less. So this is one more drawback. Next, low DC output voltage. This is one more drawback. Let's see the applications of the half-wave rectifier circuit. It is used in the illuminators for the pocket radio. Also it is used in the low-cost power supply design. Now let us summarize whatever we learned in this video. We learned block diagram of the regulated DC power supply. Then we learned half-wave rectifier circuit in detail, its working, different waveform. Then we discuss its different advantages, disadvantages and applications. In the next video, we will learn another type of the rectifier circuit, that is full wave rectifier. So keep learning. These are the reference books which are used to create this video.